So here we are in front of a Yamaha KX88 controller board. Many wonderful features on this particular controller. One of the key things was its 16 what Yamaha called code memories, allowing from the panel a recall of the various settings for controllers, power switches and so on. However, the ability to save and restore those, not so hot. The way Yamaha designed it was that you would be able to initiate a SYSEX dump from another KX keyboard, and so by linking two together you'll be able to input and output the configuration set. This is quite important because the board's MIDI implementation can quite often get overloaded and cause a need to do a factory reset. So the way to ensure that you can do that is to enter the SYSEX dump request via the panel controls. So if we were going to do it the old-fashioned way, we would move into controller assign mode and then press and hold mode for a second. It moves into parameter assign mode. Then we go all the way over here to bank A button number 16 for manual data dump. Hit that, and now it's basically awaiting our instructions for the SYSEX. So this is a very simple string we need to enter, but we must enter it in hex, and it's important to note the top of the bank B buttons is the hex legend. So the first one we need to enter to start a SYSEX message, of course, is F0. You can see it's displayed in the top bank display. And then we'll enter the code for Yamaha, which is 43. Again, it's displayed up here. Then we need to select the channel that we're operating on. In this case, we're going to do channel 0, so that is 2, 0. And then the hex for initiating the dump itself, which is 7E. And then, as you would expect, we conclude the SYSEX message with F7. So we've entered our data, and now we'll go ahead and press manual data dump. And the machine is basically now sat waiting for the reply, as it were, from the connected keyboard, which would be another SYSEX message of the code memory configuration. Now, one of the things that Yamaha suggests doing is, instead of doing that every time you want to request a SYSEX dump, would be to actually save that in what they call a universal parameter, which is not a bad idea, but doesn't help you in the situation where you've had to reset the board to the factory settings, because by doing that you will have cleared that universal parameter memory, and therefore you don't have the single button recall of that. Now, the good news is we don't need to worry about doing this from the panel when working with a software-based SYSEX utility. So I'm just going to come out of the parameter mode there, and I've just made one simple change to the configuration on this board for the purposes of the demonstration. If I flip the MIDI channel display here, you can see that for this bank, this memory bank, bank A's MIDI channel is 11, whereas in the factory setting it would be number 1. So that's the difference between the factory settings in code memory 1, I should have said. So I'm going to go into controller assign, and then I'm going to hit the load button, which again is 16, and then on bank B buttons I'm going to select bank number 1 and come out of controller assign mode, so I'm in play mode again, show again. That's loaded code memory 1, and the MIDI channel is 11 for bank A. If I go to controller assign again and load, and this time load bank number 2, come back out and hit the MIDI channel display, you can see that it's now on channel 1. So that's just to demonstrate the change. They're both in dual mode. Now, one important thing to note is when I entered that manual data dump SYSEX, I used channel 0, which means MIDI channel 1. So for the next step to work, bank A must be on channel 1. So if I change the channel assignment, you need to load the appropriate MIDI channel. So I'll just show you that as well. If we go back to controller assign and this time load bank number 1, which you'll remember has a MIDI channel of 11. I'm also going to hit it into single for the purposes of the demonstration. So we're only using bank A as an output from this board. So I'm going to change that MIDI channel now just to demonstrate that. So go into controller assign, and we actually have a dedicated button for that, button number 11. And you can now see which one is selected. I'm going to select bank A, so it's now flashing, and then using the buttons in bank B, it changes it to 1. So that's how we temporarily change the MIDI channel. Anyway, the point here is that it must be on the same channel here for bank A as what we include in our SYSEX, which initiates the memory dump or requests the memory dump. So we now move on to the computer and see how we go about doing that. Here we are over on a Windows PC running MIDIOX. I have a very straightforward, simple, cheap and nasty USB single port MIDI interface here hooked up to the KX88. We could of course be using other software here, either directly in a DAW, or we could be using MIDI Monitor or SYSEX Librarian on the Mac. But MIDIOX lets me show the important settings a little bit easier. Now I've also filtered my monitor input and output here to hide basically the active sensing, because that just gets in the way of the display. I'm going to lean over and hit a couple of keys on the board, and you can see that the input is functioning as expected. Now the KX88 has a quite useful but also very early MIDI implementation, and the output on the KX88 is effectively a through, so it basically echoes whatever comes in through the import out via the output. So we can quite easily get into a MIDI loop problem if we don't configure our software correctly. So I've gone ahead in Route 66 here, and as you can see at the top, I've disconnected the MIDI input from the MIDI output to avoid that MIDI loop problem. I also have configured the buffers here, and this is very important. If we don't do this, then there won't be enough buffers in order to send the complete configuration. We'll get a truncated message, and of course when you then attempt to send that message, there's no validation of it, it will just fail. And also, if we don't configure the buffers here, the board itself, when it receives messages, will kind of blow up and display error panel on the panel of error number 3, which is actually interrupting the active sensing. So I've set the buffers here to 10 for each input and output. It doesn't need to be that much, but the default of 2 is not good enough. So in order to replicate initiating a SYSEX dump from the panel of the instrument, it's a simple question of opening a file that contains that same SYSEX. So in this case, the computer effectively is pretending to be another KX88 or 76, and we're going to go ahead and from the command window choose to send receive SYSEX. So we'll send that string and we will receive back 2356 bytes, which is the expected length of the 16 code memories. and we can select done here. And if I just move this out of the way a little bit, you can see on the input monitor the various buffer frames. You can see a lot of them are effectively empty, and that's the code memories that haven't been altered. I can then go ahead from the display window menu, choose save as, save that out as a file, and that configuration can obviously be replayed later on. And we can do that for as many different configuration sets as we might want. Sending data is even easier. We don't need to put the KX88 into sort of a receiving mode or anything like that. We can simply open up a file, and I've got one here of the factory settings, and I can just go ahead and in this case do send SYSEX, and you can see the data is being sent over in the output monitor here. And that's all there is to it. It's very straightforward, but there's two important points to note: the MIDI loop issue and the buffers. We'll now go back over to the board and see what's happened based on the receipt of this information. So here we are back at the board, and you can see in the bank B display we have AF, which is Yamaha speak for all functions received. Now, one important point to note is the board configuration is still in the same configuration as the currently selected code memory. So it's not until we load the code memory or power cycle the instrument that those changes will have taken effect. So note the board is in single mode here at the moment. I did that deliberately, and if I go ahead and choose controller assign, and over here I'm going to choose load, and then I'm going to load bank number 1 and come out of controller assign. It's now loaded code memory number 1, and you can see we're in dual mode, and now all of the settings in this particular example have been set back to the factory defaults. That's not so useful, of course, because I can set the board back to the factory default simply by holding A and B down and powering up the instrument. But you know, I would have a similar file with all the various controller assignments, parameter assignments, universal parameters, etc. For various performances. So there you go. It's quite simple, just a couple of things to watch out for. I hope you find this useful.